All right. So here we are. We worked on number 1 last Friday, is that right?
Yeah.
And so I want you to do number 2 right here. Find where the function. I'll go over it in just a second.
We did not do number 1.
We didn't do number 1?
No. Yes, we did. We did. Oh, just kidding. Yeah, we did.
All right.
I love it. I was just on the wrong page.
I'm still looking at it. I'm still gathering thoughts.
Gather
I
thoughts.
was 10 anyways.
Huh?
I was 10.
I don't know if we talked, did we talk about it last year?
I was on for like 3 hours trying to get
Yeah.
to
Did we talk about last year, that asked the question if you were a doer or a thinker? Did we talk about that?
Definitely an overthinker.
Yeah, yeah. I don't do it.
Like, what happens is,
Just this picture.
like, the doers will come in and they'll just start working on stuff. But the thinkers will sort of look at it and just kind of try to figure things out, and they'll just be taking time, and then they might daydream off of stuff, but just kind of, so it's an important question to ask. Are you a doer or are you a thinker?
Definitely.
Now, you can be a combination of both too. It's not a purely one thing or another.
Combination of both. It really like depends.
It depends. And I think what you want to be is you want to be flexible enough to know when you need to be what.
I want to be smart. Smart enough where you don't even have to teach it. I just know what to do.
Yeah, well, that's,
Can't relate.
yeah, but a thinker, to me, what's happening is, I think the way the world works is transitioning more to favor thinkers than doers, because the computers are the doers, can be, but the thinking, what to ask the computer to do, that's what's becoming more valuable, I think.
Ask the computer, hey, can you
Aaron.
type anything before you listen?
Okay, anybody look at number, what did you do for number 2?
I did the different square.
Yeah, you gotta hit that different square.
Different squares,
Get the
okay.
canceling going.
All right, let's look at that.
You know what's up.
But to me, number 2, part of the problem is just understanding like what is being asked here. But let's go ahead. I think we're going to go ahead and do what Kylie suggests here. If we go ahead and put this here as like x plus 2, x minus 2. Is that what this is here?
Yes.
So x plus 2.
What?
So then what?
Then the x plus 2's cancel out. And then I plug it in.
So you plug in f of
Do you like it?
f of negative 2 is equal to
Negative 2
Negative
minus
2.
2, which is
negative 4, right?
negative.
So if for the function to be continuous, what does f of negative 2 have to be? It has to be negative 4, right? And so basically, what are they asking here?
Like,
Okay, they're telling you the function is not continuous because we know the function is not continuous at x equals negative 2. But to make this function continuous, what do we have to plug in? Well, we have to plug in this point, negative 2 comma negative 4, and then that would fill in the Hannah said point, fill in the,
Function. Fill in the gap.
Hannah said point, but fill in the, what do we call it more technically correctly than point, but related to point? Fill in the, starts with an H.
Oh,
no.
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 Fill in the hole.
Fill in the hole, thank you. But it's related to point, right?
See, I have a G.
The whole, so the point,
About filling in the hole.
what it is, it's not a point but the point would be like, conceptually, the point is the position, but it really is a hole, okay? Which is where we call it, which is why we call it, which is why we call a hole a what kind of discontinuity?
I don't know, you don't
Point.
A point
Oh,
discontinuity.
see, I was right then.
When are the stickers gonna make a comeback this week?
I don't know,
I
it's-
answered Tony, but Aaron,
No, that's good, because you guys thought of it. Okay, I appreciate the thought, Kylie,
thank you.
and Hannah, Aaron.
Where's my sticker?
You need the
What I need to do
stickers.
is I didn't get that stamp, and can I just stamp a star on your
Yes.
forehead?
Yes. I got room, I got plenty of
Not my
room.
forehead, though, that's what I'm trying to say. You really can't do it.
All right, let's go on here, guys. Good job. Good job.
Sorry,
You know where else I got plenty of room?
All right. For what value
Into that one.
of the constant c is the function g continuous over all the reals? So go ahead and look at this one here. This one here will probably involve continuity, but what do you have to have before you have, what do you have to have continuity?
The limit has to exist.
The limit has to exist. Okay.
Is the camera on? Or am I talking? No.
Oh, see, that's, see,
It's
blink,
blinking.
blink, blink, blink.
Man! Man, Carl! Huh?
And something on the stove. Tony Brown.
Okay, what did you do to start out this thing?
You gotta make them equal each other.
Yeah.
Yeah, so what it is we already know, because the three things we have to have for continuity to exist are, first,
F of C is defined.
it has to be exist, right? And we know it has to because of this
What?
equal to, right? Now, the next thing is the limit. So the limit, as x approaches 3 from the left side of g of x equals what?
The limit as x approaches 3 from the right side.
Ribbit.
Okay. And so what do we plug in here next?
You make cx squared minus 1 equal to cx plus 1.
So cx, and I'm going to put the left side over here. So I'm going to put cx plus 1 equals cx squared minus 1. And now what will we do? Plug in 3. So c times 3 plus 1 equals, no, I put it 3, I put
What?
okay, so what next here?
Yeah, simplify.
So you see plus 1. And then
Subtract the 1.
subtract the
Or
1.
you can add the 1. I added the 1, I guess.
Yeah, let's add 1 here. Yeah, I think that's easier. And then subtract 3c, right? So now, So now what do we have left? We got 2 is equal to 6C, is that right?
Yeah.
So C is equal to,
1/3.
C is equal to 1/3. Okay, so, and just, you can plug back in to check, but is that what you guys got for this one?
Yes.
Yes, indeed.
Okay, good. Okay, questions on this, and what happens is, a lot of the problems we're gonna have are ones where you're gonna have like C or K, and you need to solve for, and so forth, okay? So, that's what it's gonna look like, problem, right? So. I want to take a look at the camera here, though, to be sure. Yeah, it looks like it got on there.
Ribbit. It's not even that funny.
It is all good, really.
I'm doing my work.
Got it.
Okay. Why, and it doesn't say, doesn't really say, but it's assuming here that C is right here. And can you see what's happening here? Why is each of the following graphs is not continuous at x equals C? So a discontinuity, even though the function is defined in this one here,
It has that point,
just has a hole there.
a hole.
And it kind of looks like a point, the graph, it really is. And then this one here is, 3 is what kind of discontinuity? Jump discontinuity, very good. So just different types of discontinuities here, okay? Next, determine if the function is continuous or discontinuous at the given number and justify your answers. And so what conditions are you looking for on this?
If FC is defined.
Defined,
If the limit exists.
limit exists.
And it's a limit and FC is equal.
So what Kylie said is there's 1 defined, 2 limit exists, and 3 if that value that is defined equals the value of that limit. So you look back at conditions 1 and 2. In this case, do you know the limit exists? On 4, do you know that the limit exists? Why do you know the limit exists?
It has to put a count.
The reason you know the limit exists is why? What side covers the left side? Which part covers the left side? This one, right?
Yes.
Which covers the right side?
That one.
Same thing, right? And so, are you sure the limit exists? Yes, you are. So what is it you really need to find?
The limit.
The value of the limit.
I'm hungry, Mr. G.
All right. So what did you find for the limit?
Yeah. Oh, I haven't even started. I'm gonna guess 7.
Yeah, so
That's what I got.
7. So limit,
What?
as x approaches -3 of f of x is equal to -3 squared minus 2. Looks like it is 7 to me. So is the function continuous? No.
No.
So how would we articulate that?
In my head, it's 7 and 5 are equal, but I don't know if that's right.
Okay, let me show you here. Limit as x approaches -3 of f of x equals f of -3, yes or no?
No.
No. Therefore, not f of x, not continuous. At x equals -3. Okay. And then we have number 5.
Yes. We do have number 5.
So you're saying continuous, number 5?
I've done it.
Oh, I haven't done it yet. I was just saying, like, yeah.
Oh, you do have number 5.
There is a number 5.
There-
I think it
yeah.
is continuous.
Yeah.
Whoa, wait, Mr. G. Wait, there's 2 number 6s. There's 2 number 6s.
I saw that. Wow.
Oh, you mean down here?
Yes.
Yeah.
Look at that. No.
But they're different.
I think
The same
number
number.
5 is continuous.
You think continuous here?
Oh, well, I'm gonna
Whenever I did the difference of squares, it came out to like
Yeah.
6,
So,
which is the same as x equals 3.
so we have, so condition 1, we know f of 3 equals 6, right? And limit as x approaches 3 from the left side of f of x equals limit as x approaches 3 from the right side of f of x. And then we could just fill in here, we got 3 squared over, that's a 0 minus 0, right? So you had to factor for this, didn't you?
Yeah.
Let's factor it out. Yeah, I just plug it in, 0 over 0, didn't work. So let's go, we got, it's going to be x plus 3.
X plus 3.
So we get 3 plus 3 equals 3 plus 3.
Which is equal to
So,
I've never seen that much stone.
so limit as x approaches 3
X approaches 3.
of f of x
F of X.
equals 6
Seis in Espanol.
equals f of 3. So therefore, f of x continuous at x equals 3. Now, last year in pre-calculus, did I introduce you this dot 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 thing?
No,
Did we talk about that?
that's like.
Okay, this is
hieroglyphs
this
to
dot
me.
dot dot. Okay, this means therefore.
I'm gonna start doing that on my English papers.
I don't know if your English teacher will let you do it, but in calculus, mathematics, this is definitely. She would?
Miss Mitchell would have let us.
Honestly, I wouldn't be surprised if she actually would let us.
If you put like a key at the top that said this dot 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 means therefore, she would have been like,
Yeah.
That counts as 3 words.
Yeah.
It's 3 dots.
3
I had to
dots.
lift my pen.
3 word.
3 times.
Okay.
Why did the master?
Okay, next. We'll call this,
He doesn't want me to kiss.
we'll call this one,
6 and 6 or 2.
yeah, we'll call this one, anything, 6A, we'll call this 6A. That's 6A, this one we'll call 6B.
B and 6A.
Let's go ahead and work out 6A and 6B. We'll go over them pretty soon.
Whoa, 6B's wonky, Mr. Hughes.
6B, yeah.
You gotta do 2. They put 2 questions in 1 question.
Yeah, they did.
Technically 3 because there's 2 6s.
Exactly.
They did.
They're trying to trick us. Oh, I'll stall. Mr. What? Me too, honestly. Me too.
I just want to be smooth, like, not so productive. And then I'll get rid of my time.
I just need to make it like half as big.
Yeah,
my
I thought you said, I thought yours had twice as big. I was like, yes.
And my forehead. I need that extra 2
Can
seconds.
you get forehead on you?
I don't know. I guess you just put more hair here.
Get a hairline surgery.
Yeah.
Oh, you need the forehead enlargement.
Let me get it all the way back. I think that's just called shaving right there.
No.
Just send it. We're talking about foreheads. We got off topic. I'm sorry, Mr. G. That's probably my fault. I'm
Okay.
distracting forehead.
So, so the left side, that's going to be this guy right here, right? And we already know that's going to be -1. Is that going to be equal to this one here?
What? That was a long time.
So is the limit equal? Is that right there?
No. Wait.
I did it different. I did not do that.
Did you get the same thing?
So like,
Why did you put in a 1 there?
Yeah, why'd you use 1 on
I thought X equaled 2.
I thought it was X equals 2.
Oh, 2, like this?
Yes.
Oh, okay, then it's not equal, right?
You were wrong. I would have been surprised.
Yeah, so I put the, there we go. So since limit as,
It's 2, it makes it -1 equals 0, because the 2 needs to be, there needs to be.
The other one is
right
near
there.
2 as well.
Yeah. No, like the 2, the one.
this one here is 1,
That one's -1 and the other one
And then
is 0.
I'm talking about the one in the parentheses next to, that's on that side, the one right there. That's-
oh, okay, I see what you say. This should be 0.
Yes, sir.
Yeah, good job. Okay, at least it ends up being the same conclusion,
You did that
right?
on purpose just to test us, didn't you, Mr. G?
No, I thought, honestly, I didn't that
I'm
time.
very confused.
But anyway,
Before how they equal.
anyways, but in either case, they're not equal to each other, right? Since limit as x approaches 2 of f of x does not exist, right? Does not equal BNE.
That's what she's been watching.
Okay, not continuous at x equals 2. All right, did you work out this 6b that we called here?
I've started.
You started it, okay.
I looked at 6 for a minute and then moved on to 7, so,
So you gave up?
yeah. I decided that 7 was easier and I'd come back to 6.
Okay, well, that's a strategy.
So,
But for this one here, Aaron is right about that, in that there are a couple different things to consider.
yeah.
One thing I look at here first is I look for these little equal to things. Because if you don't see these little equal to bars underneath here, what does that mean?
That means it ain't continuous.
It means it can't possibly be
Doggy
continuous.
dog.
Yeah, so that's, what it is, just on the checklist thing, because what happens is, you're trying to go through a process of elimination. And if you look at it first and see so you would say, does not exist, or the value point does not exist. But here, we have this one over here, which is going to be limit as x approaches -1 from the left side of f of x equals limit as x approaches -1 from the right side of f of x. And then over here you have, it's the same type of thing, but you're approaching 1. Then we just fill these things in. Here's our left side, is that right? Is that our left side of -1?
That is our left side.
So we'll put in 2 times -1 plus 1
It's gonna be funny.
equals 3 times -1.
Negative uno. How do you say
Question
negative
mark.
in Spanish?
So here we'd have -1. I think it's negativo, I think.
Negativo?
I think it is.
Negativo uno.
There would be either
So is is the function continuous
Uno
here?
negativo. That's not a function, or it's not a thing.
Not continuous,
It's
not continuous. So that limit does not exist. Now for this one over here, you have, this will be our left side limit in this case, right? So 3 times 1, not -1, equals 2
Times 1.
1 minus 1. So in this case, you're getting 3 equals 1. Is this one continuous here? No. So limit as x approaches plus 1 or -1 of f of x does not exist. Limit as x approaches 1 of f of x does not exist. So therefore what? F of x not continuous where? At plus or minus 1, right? Okay. 7. So Kylie, you worked out number 7? That's right.
There was an equal sign.
Okay. Kylie, could you tell us or show us what you did on this one?
Well, since there's no equal sign.
No equal sign, right?
It means that it would.
Okay.
The limit, yeah, the limit.
Yeah, the
doesn't
limit doesn't
exist.
exist, so it doesn't work.
Like it could.
Yeah, the limit
doesn't
could exist,
Yeah, but
but
it's
what
not
does not
defined.
exist? Not defined. So since there is no, what will say, how do we say this?
I said, since the limit is undefined, it can't be continuous.
Since, it's not the limit,
F of 1.
since f of 1 does not exist. Not continuous. At x equals 1. All right?
That ain't that bad.
Yeah, so that's all there is.
Number 8 is the same as this one over here.
Number 8's the same as the earlier one we did?
Yeah.
Yeah. So go do number 9 instead.
Sure.
Are you gonna get one right finally?
Yeah, so
Yeah, do number 9 instead. Let's see what else we have here.
So what happens if we know the answer but we don't know how to work it out?
Okay, well then we'll learn about articulation. Is that where you are on this one, Aaron? Is that where you are on
Yeah,
this
like
one?
I know what A and B equal, but I don't know how to show the work.
Oh, do you?
Yeah.
yeah.
Okay. Well, what you would do is you would have a system of equations on this.
Oh, fun.
Anybody else have the same situation here?
I have an idea of like what they are, but like I really don't know where to
Okay.
prove that.
Again, what it is, it's setting limits. Setting left-hand limit equal to right-hand limit. And a limit exists if and only if,
The left side limit equals the right side limit.
okay, now Aaron just said it, right, and Kylie has said it before. Everybody needs to say that. So forget everything Aaron and Kylie just said. Gavin, you've said it before too. The limit exists if and only if.
They're equal.
Every time I say that, I should be listening to the end and say what's there.
Yeah, what is they?
Articulate.
We didn't read the answer, I was just.
Oh, he was making a funny.
So the limit exists if and only if. Left-hand limit equals right-hand limit, okay? So what we do on this one is the same thing we've done on the other ones, which is we say limit as x approaches 1 from the left side of f of x equals limit as x approaches 1 from the right side of f of x. And then we can just fill that in, so we get, here's our, what is our left side value?
Dose.
2. And the right side is going to be a times 1 plus b, right? Can we solve with this alone here?
We cannot.
We cannot. So let's go work our other one here. We have limit as x approaches 3 from the left side equals limit as x approaches 3 from the right side of f of x. And then we have negative 2 on the right side here, is that right? On the left side, we have a times, what is x? 3, right? Plus b. And so now can we solve this thing? Yeah. So we get a plus b is equal to 2, and here we get 3a plus b is equal to negative 2. Is that what you got on this thing? How would you solve from here? Again, you're just talking about algebra at this
How
point.
about you solve for B?
Yeah, solve for b. One thing you could do.
Or A? Or
Here's one thing you could do. What I would do is I would take this equation here. I take this a plus b equals 2. And I would just subtract.
Oh, you can do that?
So let's just subtract. What's 3a minus a? 2a, right? And that's 0. And what's negative 2 minus 2?
Negative 4.
Negative 4. So a is equal to negative 2. And then what is b going to be equal to? Negative 2 plus b
4.
equals 2. So b is equal to 4.
That's whack. I didn't know you could like subtract those two.
Yeah, that's one way of solving a system of equations. So it's just a little trick. Did you solve for one first and then substitute in? Is that how you did it?
That's how I would have done it.
Yeah.
That you would have done? Okay.
And I guess it would work like that. Subtract.
Okay. Ladies and gentlemen, we are to this section where it says limits and continuity review. So I want you to do
So I'm trying to go, Mr.
what I want you to do is I want you to do as a homework assignment these first 7 here, 1 through 7.
Oh,
And one thing you can do is I think 3 might take a little factoring, but 1 through 7. And so we'll call that our homework assignment for tomorrow. And the way it'll work out is tomorrow when you come to class, I plan to have all these problems worked out. So you just check your homework, and then we go on from there. Then I check if you did your homework, then you get a homework grade. What people do is they can leave their binder here and take that one page out and take it home. That's what people can do. But homework assignments for this class shouldn't be usually longer than 30 minutes. Should be usually a lot less than that. Okay? Thank you.